Okay, so we've looked at a bunch of different properties for quadratic equations. However, when we looked at the intercepts, we only looked at the y-intercepts. We didn't look at an x-intercept. So when we talk about x-intercepts, we're also going to at the same time solving a quadratic equation. Because when we ask ourselves, how do we find an x-intercept? Think back to what we did with linear equations, because it doesn't matter what type of equation we have. When we're finding the x-intercept, if we are on the x-axis, the y value, the amount that we have gone up or down, is going to be 0. So to find an x-intercept, we are going to plug 0 in for x, or excuse me, in for y. So we can solve for x again because we go up or down 0 when we're on the x-axis. So when I look at this first problem here where it says find the x-intercept of y equals x squared plus 5x plus 6, notice in order to do that I would put 0 in for y, giving me 0 equals x squared plus 5x plus 6. Now, if I were asked to solve the quadratic equation x squared plus 6 equals negative 5x, if I were to put this in its standard form, ax squared plus bx plus c, I would have to add the 5x to both sides. After adding 5x to both sides, I would have x squared plus 5x plus 6 equals 0. So notice, regardless of whether you're told to find an x-intercept or to solve a quadratic equation, you're going to end up having the exact same problem. So you're going to do the same thing. We're going to look at 3 main ways to solve quadratic equations, and then there will also be a bonus 4th way. The 3 main ways that we're going to focus on that you will have to know are how to use square roots, factoring, and the quadratic formula. In this video, I'm going to talk specifically about square roots. Each of the 3 methods works best at different points. Using square roots works best if you have a linear term that isn't there. So your b equals 0 being in the form ax squared plus c equals 0, or ax squared plus c equals some number. So let's go ahead and look at some examples of that. Before I dive into the examples, I think I have 4 examples total, I just want to look here at x squared equals 9 and x squared equals 36. If I asked you to give me a number that when it got squared, it equals 9, the majority of you would probably say 3. But notice that, and you would be correct, but notice that if I square a negative 3, I also get 9. Remember, because we always plug in with parentheses, and negative 3 in parentheses squared is negative 3 times negative 3, or positive 9. Same thing with 36. If I asked you for what number squared gives me 36, hopefully you would say 6, but then hopefully you would also say negative 6 can also give me 36 when squared. For that reason, when we take a square root of both sides, we are always going to put a plus or a minus in front of the radical to show that 2 numbers squared, what the positive or the negative of that number, can square to give me my original value. So let me show you how that setup's going to look in this first example. If I have x squared equals 49 and I wanted to solve this for x, I would solve by using square roots. Since I am in this form is when b is 0, when there is no linear term. There is no linear term, so I'm going to take a square root of the left. I will also take the square root of the right, but on the right I'm going to put a plus or minus, which that's really hard to read, but I'm going to put a plus or minus out front to recognize the fact that I could get 2 different answers. And I would get x equals, I can either write 7 and negative 7 separately, or I can just say plus or minus 7 to symbolize the 2 different possibilities. On example 2, let's look at that. So I want to again same idea, I want to find the x-intercepts of 3x squared minus 27 equals 0. Notice 0 has already been plugged in for me. So in order to solve this, to be able to take a square root, I want to get the square, the variable by itself, so I'm going to add 27. 3x squared equals 27, and I'm going to divide by 3, giving me x squared equals 9. So now from here I'm going to take the plus or minus of both sides when I take the radical, so I'll take the square root here as well as here, and I get x equals plus or minus the square root of 9, which is 3. Alright, let's look at the last 2 examples. On example 3, I'm going to solve this equation. So doing the same thing, I want to get that square by itself, so I'm going to add 24. I'm going to add 24. 4x squared then equals 25. I'll divide by 4, giving me x squared equals 25 over 4. I'm okay with it being a fraction. I'm still going to do the same thing. I'm going to take the square root of both sides. When I do, I'm going to remember to put a plus or minus out front, and I get x equals, taking the square root of 25, I get 5. Taking the square root of 4, I get 2. So I get x equals positive 5 over 2 or negative 5 over 2. Finally, last example, I divide both sides by 2. To get x squared by itself, I get x squared equals 7. From here, I take the square root. I remember my plus or minus, and I get x equals, I do not know what the square root of 7 is, so I just leave it under the radical. I ask myself, can the square root of 7 be simplified? It cannot. It doesn't have any perfect squares, so I'm going to go ahead and stop there. So a big thing to remember is square roots. Don't forget the plus or minus. I'm constantly catching that mistake on people. And I only can use square roots if my linear term does not exist.